So yeah, my name is David Danzilio. I'm a Puppet evangelist, a systems and engineer at Constant Contact, and my background is a hodgepodge. Okay, of healthcare, research, government, higher education, all kinds of stuff. But I've been using Puppet for a long time, since the dark times. And I've been able to see a lot of different Puppet implementations that definitely run the spectrum from, kind of crazy to pretty good looking. Haven't seen too many of the pretty good looking ones. So what's this talk about? I'm sure you're interested. This is a collection of my observations of the particularly highly effective Puppet users. Like I said, I've seen a lot of different implementations, and I've been able to help a lot of people get started with Puppet. And so there are some patterns emerge from the people who are using it and not really getting the most out of it, and some of the people who are getting a lot out of it. So habits. What do I mean by habits? I don't mean this kind of habit, but this is a pretty cool habit. I mean this kind of habit. I guess I should talk about what a habit really is. Stephen Covey said that habits exist at the nexus of knowledge, skill, and desire. And I think a bit more compact edition of this would be that a habit is an acquired behavior pattern regularly followed until it has become almost involuntary. And that's right off of dictionary.com. Habits are hard to acquire, and they're hard to get rid of. You don't really think about habits when you're doing them. Habits have a built-in feedback loop, and they're things that you do really without considering the alternatives. So here are the habits. There's think like a software developer, treat Puppet like code, stop, drop, and design, test all the things, continuous integration and deployment, make nice with Ruby, and finally get involved. So the structure sort of, I'll talk about a habit, and then I'll talk about some of the things that you can do that sort of help you acquire this habit. So we should probably start with the first one, which is think like a software developer. So the first habit of highly effective Puppet users, think like a software developer. It came out of the idea that Puppet has sort of fundamentally changed our roles, right? Newsflash, Puppet has fundamentally changed the field of system administration, like so much so that you really can't consider yourself a system administrator anymore. You're a software developer. And I'm sorry, I know this is a drag for some of you. This might not be what you signed up for. When I started working in system administration, my background is in system administration. I'm not a software developer. And actually, I don't have a computer science degree. I have a political science degree and a business degree. So this was sort of like an aha moment for me, was that, I'm not doing system administration anymore. I'm doing software development. But once you realize that, you have to sort of figure out what does that mean? Like, what does it mean that I'm a software developer now? But the sooner that you realize that, the easier it will be to adapt, and you can start actually learning what it means. So, like I said, it's not your fault that you suddenly become a software developer, but it is your job to figure out what that means and what a software developer is supposed to do. So, important to note, system administration, not software development. These are two completely different skill sets. I mean, until very recently, software developers having root access was sort of what sysadmin nightmares were made out of. And even for a lot of people, it still is. It still is. We expected system administrators to step into the role of a software developer, but we didn't stop to think that maybe these sysadmins could use some training first. I don't know. Why do we think this was easy? What do you think would happen if you took a airplane pilot and asked him to design a jet engine? I think you'd rather not be the test pilot for that prototype. I wouldn't want to be it. But this is exactly what we did. And we thought, Puppet's easy because it's a domain-specific language. One of Puppet's strongest assets is that it has a DSL, right? It's easy to understand, powerful, quick to get up and running, but it's also a pretty big liability, right? We thought that the DSL meant that system administrators could write good code without having to learn what good code really looked like. We thought that we had abstracted all the hard stuff away, but we were wrong. We just made it really easy to write bad code. And so the DSL gave us this like false sense of security, and we fell for it. And I've seen like a lot of really bad Puppet code. You can't expect people to be good at something that they've never done before. This sounds pretty simple on the face of it, but there's a huge disconnect. We said here, go become software developers, but I'm not going to tell you what that means. So in this episode, Bones says, I'm not a doctor, I'm an engineer, and to which Scotty replies, now you're an engineer. And we've just got to face that fact. Sorry. But the good thing is that software engineering is a pretty mature discipline. People spend a lot of time trying to figure out what good software looks like and how to write good software. So we can start to take advantage of this pretty vast body of knowledge once we understand that Puppet is simply another language. And this is actually particularly important in Puppet 4, or the impending changes to the language in Puppet 4. It'll get easier, but as the language starts to take on more qualities of a general purpose language, we're going to need to understand the implications of that. So people are going to have to understand, basic things like looping and stuff like that. And you may think it's simple, but I don't think it is for everybody. So on a related note, the second habit is treat Puppet like code. So along the same lines of Puppet being a DSL and it being declarative, is that it's been sort of hard to keep the focus on Puppet as code. It doesn't really look like other languages. It looks kind of funny, and people have a hard time conceptualizing it in the same way. So stop thinking of Puppet as just a collection of configuration data. Puppet is a tool for infrastructure as code. Code is in the name. It's code. This is programming. But there are some very specific things that really need to happen in order for you to take it seriously and treat Puppet like code. The step 0 is version control. And the keynote this morning, Gene Kim, it's a significant predictor of how effective the organization is, right? And everybody, most people are sitting in here are like, okay, he's telling me to put my stuff in version control. How good is this talk going to be? But there are people that I know, people that I respect, people in this room that still don't have their Puppet in version control. But there's no excuse, right? So I've gotten together a list of version control systems. There's an endless supply of them. And there's bound to be one to satisfy the hipsterist of hipster puppeteers out there. So pick one. Documentation. You're not the only person on the planet. At some point, someone else is going to have to read your code. There should be just enough documentation to allow someone to step in and understand what your code is doing, and what it was meant to do. This isn't just for other people. How many times have you tried to extend a script without documentation? You're, usually stuck spending a shameful amount of time reverse engineering at first. We've all been there, I guarantee it. So at the very least, you should have a README, explaining how to use your module and what it's doing, right? You can't tell people to RTFM if there's no M, okay? You should also have inline documentation. This is an NTP module. It has 114 lines of documentation in its public class. I shouldn't have to dig around and debug your code just to figure out what a parameter does, Refactoring. This is something that sysadmins haven't had to do, right? There was nothing to refactor before infrastructure as code. So good refactoring, focuses on eliminating complexity, improving readability, removing duplication, and improving documentation, and the general focus on reducing technical debt. And I learned this yesterday. Code in need of refactoring is smelly. It's called code smell, and I think that's great. So I was asked by my boss to represent the company well and to not curse on stage, and I was going to ignore that until his boss decided to come. So I went through. I figured I'd be a good company man and fall in line. So, I think that refactoring is essential software maintenance. Not refactoring will make it harder to keep your code base up to date. Code review. Code review, have a human review your code, right? You still have to test it. It still has to go through your pipeline. But, this allows for collaboration and, increased awareness of the direction the code is going. It's actually a better, communication tool than anything. So style. Style is important, not this kind of style, but adhering to a consistent style ensures that everybody understands what's happening in the code. This is especially important if you're developing modules in a distributed fashion. A lot of times style can take a back seat to efficiency or urgency, get it done now. But really, it doesn't take a whole lot of work. Think about the cost of sifting through lint the next time you try and extend somebody's sloppy code. And the community has made some really great tools out there to help do this for you. Puppet Lint is a fantastic tool. It can help you analyze your code for style guide compliance. Like every module should have this. I mean, it should be run through Puppet Lint. There's no excuse. So the third habit is stop, drop, and design. And I think that one of the biggest habits for effective Puppet users is a tendency toward design instead of just sitting down and writing. So I think a good example here, New York and Boston. New York had a design and Boston didn't. We just put the roads down wherever the horses went, So designed by horses. I don't. I love Boston. So software needs to be designed, and Puppet's no exception. Some design principles: separation of concerns. You separate your code into distinct sections, each that address a separate concern. This results in modular code with well-defined interfaces. Separation of concerns has been around since like the 70s. And it's like so common in software development that people can't even put a name to it. They really can't even, package file service. This was one of the first patterns in the separation of concerns sphere that emerged in Puppet. You break up the implementation of your module into a couple of different classes. One installs a package, places a configuration file, another implements the service. And usually you orchestrate them through a public class. This pattern works great for small modules, but the same principles can be extended beyond that to more complex modules. Rows and profiles is another one. This implements separation of concern by introducing new layers of abstraction, roles and profiles. So it allows you to construct fairly robust and organized code. It allows you to wrap Forge modules, so you don't have to pull them down, change them, and take ownership of the life cycle. When you're designing Puppet code, you need to look at identify your interfaces. You need to focus on limiting your entry points and keeping your interfaces simple. So when you're trying to identify your interface, you should ask yourself some questions. Like, what information does this module need? Where is that information going to come from? Is it going to come from a fact? Is it going to be manually added into a parameter? And then where does it need to go? Answering these questions will help you identify your interface for your module. Public and private classes. Identify which classes are public and which are private. Public classes end up looking a lot different than private classes. Public classes are where you define your module's API and through its parameters. And public classes should basically just validate your inputs and pass the data to private classes. So public classes should be really absolutely the only way that a user can interact with your private classes. And there's actually a function in the standard lib. It hasn't been released yet. It's in trunk called private. I think it's great. Take a look at it. Data separation. You want to understand how data flows through your module from your public to your private classes. It should be pretty easy to pinpoint where the values of your parameters are coming from. Obviously, data in your Puppet code is bad. Data inside your Puppet code makes it essentially a singleton, right? If you want to fulfill any other use case, you're going to have to go in and change your code. So it hinders abstraction and code reuse. So like embedding things like package names, version numbers, URLs, host names, you're like virtually guaranteeing that your code's going to need to be written if your use case changes. Hyra is a great way to get your data out of your modules. It's been around for a while. It's well known. It's under pretty active development. So if you're not using Hyra, you should ask yourself what you need to do to start doing it. Like right now. Params is another way. It's fairly early, or fairly early pattern that emerged. You get your default data into a separate params class. Then there's data in modules. This is an emerging pattern, really, where you have a separate hierarchy for each module. There's been a lot of talk about it. It's kind of controversial. We're waiting to see how it's going to be implemented in Puppet, and there are a couple of other implementations you can take a look on the Forge. I'm not really going to go into it too much, but I think it's definitely worth looking at. Stability is a key feature of enterprise software, and it's something that you need to think about from the beginning when you're designing your module. Your users want to know that your software is going to behave consistently and predictably, right? So your Puppet code should probably have these qualities. You want to identify a stable feature set. Identify the features you want your module to have. Track them, write them down. Make sure these features aren't accidentally removed. It sounds kind of silly, but it can happen pretty easily. Semantic versioning can help your users understand how your code has changed between versions. Very easy to implement. It helps ensure that there's a sort of a method to the madness. Simplicity is definitely an often forgotten design principle. Your Puppet code should be easy to understand and do like as little as possible. It should be very narrowly targeted to implement your desired functionality. Keep the Unix philosophy in mind. Do one thing and do it really, really well. And focus on your module's core functionality. And sort of like an example of this, I hate Forge modules that include monitoring. I guarantee that my Nagios implementation looks nothing like anybody else's Nagios implementation in here. I guarantee it. So don't force me to rewrite your module because you thought including Nagios checks was a good idea for your like log rotate module or something. It's well intentioned, but it doesn't work out all that well. Hooks. Another thing that I love are hooks. Provide hooks to enable or disable functionality. An example would be here we get a JabberD class. I can manage package, repository, or service if I want to. So I can opt to use a custom package or a custom repository, or if I want to use some service, service mechanism that nobody has heard of. This can be helpful for organizations that have their own, practices for these things. Write modules as if they're going to be open source, even if they're not, right? This means designing them really with somebody else in mind. So you make them flexible and make them easy to use and hard to abuse. Test all the things. It wouldn't be a tech talk without this guy showing up. So I want to code, but I don't want to test my code. So testing, especially for us who grew up in the sysadmin track, it's not very intuitive, but ops folks are generally pretty receptive to it. Anything that means that I'm going to be paged less, it sounds pretty good to me. So The great thing is the tool chain has improved dramatically just over the past year. It's gone from pretty terrible to actually pretty good. Testing has become relatively inexpensive. Investing in tests is a pretty big financial decision, but much cheaper than it used to be. And this is really thanks in large part to Vagrant and sort of cloud computing and all this stuff. And really Vagrant sort of revolutionized the way we develop software, right? If you aren't using Vagrant, you should be. Spinning up a Vagrant box to test your code is so inexpensive. It should really be at the center of your development process. And your infrastructure is too important not to test, right? The software development community has nearly universally accepted testing because it works. I don't want to hear this, right? So how? There are a lot of ways to do this. Puppet syntax is a great gem. Checks to make sure your Puppet code, templates, and hire data are all valid. This does nothing more than ensure that your code will parse, so don't fool yourself into thinking it's a good test. It won't catch runtime errors. RSpec Puppet is just a fantastic tool for writing unit tests for your Puppet code. Beaker, integration testing framework. It can be used with Vagrant or some other cloud provider to ensure that your code actually does what you expect it to do. Beaker will spin up a virtual machine, apply your Puppet code, and run a test suite to make sure that the end state of your machine matches what you've outlined in your Puppet code. This is super powerful. Kitchen CI is sort of Chef's implementation of it. I like it too. They've got there's a great Puppet provisioner out there. It's pretty simple. But the back end, I guess, of both of these tools is ServerSpec. ServerSpec provides a DSL for testing things, for running tests on live infrastructure. So yeah, here are a couple of ServerSpec examples. Describe package HTTPD, and then I say it should be installed. How long would that take to do by hand, right? The service should be enabled and running, and then port 80 should be listening. This is a very simple test, but this stuff would be really hard to do. It would be pretty expensive to do by hand. So I get asked, why should we test Puppet a lot? It all boils down to complexity. Puppet has turned out to be a lot more complex than we thought it would be. So you need to test modules because they take arguments. They contain logic, and they interface with other elements of the system. So don't be this guy. Just I should write some tests. The best way, and I promised there would be a cat in this presentation on Twitter an hour ago. So here it is. Test first. The best way to test all the things is to write your tests first. Test-driven development results in better code coverage, simpler implementations, more loosely coupled designs than the traditional test last approach. And if you're interested, there are plenty of really great talks today and tomorrow on test-driven development. And there are some really good ones online from PuppetConf and Puppet camps past. So make your tests count. You want to focus on the interfaces and the logic. You don't want to just rewrite your module in RSpec because that really doesn't help anybody. I think the first step to writing tests that count is actually test the functionality that you care about. So like I said here, this test tells me nothing. It's not particularly insightful. It's basically just recreating the Puppet code in another DSL. And it really doesn't tell me anything meaningful about the SSHD config file. A better way to implement a test or something like this. I check and make sure that SSHD config has the content that I expect it to, right? This tests the interface. It tests my port parameter. And it ensures that the port parameter is valid and that it's actually getting into the resulting file. Continuous integration and deployment. This is probably the strongest indicator of how effective a Puppet user is, I'd say. Continuous integration, if you're not familiar, is where developers merge small amounts of code frequently, very frequently in fact, instead of large amounts of code infrequently. So this results in, this reduces the amount of code in each integration, which ultimately reduces the risk that an integration will fail. So this allows you to develop and release software much faster. But the first thing you need for continuous integration and deployment is a pipeline. Your pipeline is a fully automated list of steps that your code must pass in order for it to come out the other end. Usually, a developer commits to a repository, and this kicks off the pipeline. So your deployment pipeline should be the only way for a new module to make it into your environment. And if anything, you want to do continuous integration for Ryan Gosling. Automated testing. This is one of the central components of your pipeline, a fully automated test suite. Your test suite should be robust and rigorous in proportion to the importance of the code. We don't need, don't forget the business decisions here, right? And there are a few different kinds of tests that you can run, right? You can write unit tests. Unit tests are written in RSpec Puppet, and they test to make sure that the individual units are functioning as expected. These are the tests that where you're only testing the functionality of your module in isolation, right? You're testing the smallest unit available. They generally focus on testing logic and stuff like that. These are the cheapest type of tests, but they're also not the most helpful tests. There are integration tests. Integration tests can be written in RSpec Puppet or Beaker or Kitchen, something like that. And they focus on the integration between classes and modules. These focus on testing the interfaces and seek to ensure that the APIs of your module are functioning as expected, right? They're much more expensive, but they give you a lot more coverage and a lot more confidence. And then acceptance tests. Acceptance tests are written in Kitchen or Beaker, and they ensure that your code actually does what it's supposed to do in real-world conditions. These tests actually run your code and make sure that the end state of the system matches what you've defined in Puppet. These are extremely expensive, but they're the most accurate and they provide the most feedback. So it sounds kind of silly, but test under real-world conditions. It's important to remember that your tests are only as good as the conditions under which they're carried out. If you're a 100% Red Hat shop and you're testing your modules on a Windows box, you're probably going to run into some troubles. This is a very old picture. You're trying to avoid this problem. If rule number 1 is to make your development environment match your deployment environment, then rule number 2 is to make sure your testing environment matches too. So your test results need to be reliable. In order to achieve this, you need to take a really good look at your environment, and you need to build a matrix of platforms and software versions and such. And then this will be resource intensive, but it's pretty important that your code works across your entire environment. So what kind of things do you want to test with? If you have multiple Puppet versions in your environment, you want to be testing all of them. It's also a pretty good idea to test the most recent version. Operating system versions. If you have more than one operating system in your environment, you got to test all of them. Ruby versions. I've seen some really weird things with the same version of Puppet on different Ruby versions. So you want to test every single version of Ruby in your environment. And then dependencies. I see a lot of people testing with just whatever they pull down from the forge, and they don't stop to think, well, maybe we're using a different version in production. This is something you need to think about. Test with your actual dependencies. And then automated deployment. Once your code has succeeded, it's ready to deploy. Or your tests have succeeded, it's ready to deploy. You can opt for like a zero-touch deployment or a one-touch deployment, or it should be automated and it should have as few touches as you feel comfortable with. There's library in Puppet, R10K, mcollective, Capistrano. This is just 4 of them. There's too many to list. Just make sure that your deployment is automated and easy to orchestrate across multiple Puppet masters. 6 is make nice with Ruby. I know this is sort of like a religious war, and I sort of hate to dive in, but it's really important that you understand that Puppet is written in Ruby. You're going to need some Ruby foo. Puppet is in fact Ruby, right? All the tooling around module development has grown up in the Ruby ecosystem, and as a result, Puppet module development ends up looking a lot like Ruby development. So I suggest to get over it. I'd recommend that you cast aside any language dogma and dive into Ruby. It'll make your life easier, and in the end, it'll make your approach to Puppet more robust and informed. You don't have to be this guy, but you're going to have to use tools like Rake and RSpec and Bundler and Guard. These are all things, they all have DSLs, or you're going to have to know how to use them. And then if you want to write custom types for providers or facts, you're going to have to implement those, well, generally in Ruby, right? And really, if you want to do anything advanced, right, you're going to need to know Ruby. The last habit is to get involved. Highly effective Puppet users share their knowledge with others. They get involved with the community and keep up to date on where the community is going. So, but getting involved is not entirely selfless. Puppet, is open source and very heavily, community driven. This kind of goes without saying since we're at PuppetConf, but you need to be involved in order to know what direction the community is moving in. I've seen a lot of people fall behind because they didn't have their ear to the ground. So, and it's also important to note that your experience, whatever it is valuable. No two Puppet implementations are alike, right? Puppet is still fairly new, and we need contributions from everybody in order to identify design patterns and best practices and help the language advance. So what can you do? You can share your modules. Put your modules on the Forge or on GitHub. Let people contribute to them. Let other people do your job, right? Take advantage of the active community that Puppet Labs has worked so hard to foster. It's a pretty great community to get involved in. You can speak at conferences. My first time speaking at a conference was actually a month ago, and it was at PuppetCamp Boston. Since then, I've spoken at, this is the third one in the past month. So, Puppet hosts Puppet camps annually in a bunch of different cities around the globe. If you can't make it to any of these, get involved with a user group or start one if you don't have one in your area. And check out Puppet Lab's website for slide decks and videos and stuff like that. They're really great. Answer questions. There's ask.puppetlabs.com. There's the Puppet IRC channel, Google Groups, all kinds of stuff like that. There are plenty of people out there asking, but not enough people answering, right? So dive in. And blog about it. That's the end of my talk. Do you have any questions? Let's get a mic over here. Thank you.
Will this slide deck be available?
Yes, it will.
And also, being effective looks like a lot of work.
It is. I'll be up here. Thank you. Nice.